Welcome to my maths class, 6th class mathematics, semester 2, mensuration. In the previous video, we have seen that how to find the areas of irregular shapes using grid paper. Now we will see finding the area of certain figures made up of straight lines. For example, find the area of the shape shown in the figure. This figure is made up of line segments. Therefore, we can find it easily. So, we will count how many full squares were there. One full square, two, three. Three full squares were there. So, number of fully occupied squares, fully occupied squares is equal to 3. So 3 square centimeters. Next, number of half squares. Number of half squares is equal to, this is 1 half, this is 1 half, 2, and this is 1 half. 3 half squares were there. 3 half squares. 3 half squares. Half square centimeters. 3 half square centimeters is equal to 1.5 square centimeter. 1.5 square centimeter. Therefore, total area of the surface, shown in the figure is equal to 3 plus 1.5. 3 plus 1.5 is equal to 4.5 square centimeter. Therefore, area of the figure, area of the shape shown in this figure is equal to 4.5 square centimeter. We have determined this using grid paper. Next, coming to the exercise 10.2, there are certain shapes on the grid paper. We will find the areas of these papers using this grid. Each slab is equal to 1 square centimeter. Therefore, in the first figure, this is a square, we will count how many full squares are there. All are full squares in this figure. Therefore, we will count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 square centimeters. Therefore, area of the first figure is equal to 9 square centimeters. Next, taking this one, here also 1, 2, 3, 4, 5. Only 5 square centimeters were there occupied by the figure. Therefore, its area is equal to 5 square centimeters. Next, coming to this figure, there are some half squares and one full square. Therefore, we will count it. It is a half square, and this is also a half square. 2 half squares and 1 full square is there. So, area of the third figure is equal to 1 full square plus 2 half squares. 2 half squares. Therefore, 2 half squares, 2 halves is equal to 1. 1 plus 1 is equal to 2 square centimeters. So, area of this figure is 2 square centimeters. This full is 1.5 plus half 1, 2 square centimeters. And going to the next one, here it is occupied by 1, 2, 3, 4. 4 full squares. Therefore, area of that figure is equal to 4 square centimeters. Thus, for the figures made up of straight lines, we can easily find the area because they contain only full squares and half squares. So that is easy. Thus, we can find the areas of some figures formed by straight lines. So, going to the next problem. This figure, there are some irregularly shaped figures and 2 shapes made up of curved surfaces. Therefore, we get half circles, half squares, centimeters, less than half square centimeters, greater than half square centimeters, full 1 square centimeters. Therefore, we will find the area like this. Number of square centimeters, fully occupied square centimeters, plus number of half square centimeters. Next, number of greater than half square centimeters. We do not need number of less than half square centimeters because we neglect them. Less than half square centimeters we neglect them. Only the greater than half square centimeter is taken as 1 full square centimeter. Half square centimeter is taken as half square centimeter. Full square centimeter is taken as full square centimeter. So in this figure we will see how many are there full square centimeters. 1, 2, 3, 4, 5. 5 full square centimeters are there. So we will fill this table 5. Next, half square centimeters. There is no exactly half square centimeters. No exact half square centimeters. Therefore, we will put a dash. Next, greater than half square centimeters. 1, 2, 3, 4, 5, 6, 7, 8. There were 8 greater than half square centimeters. We need not find the less than half square centimeters. Therefore, total area is equal to 5 square centimeters plus 8 greater than half square centimeters. Each one greater than half square centimeter is taken as 1 square centimeter. Therefore, 8 greater than half square centimeters are equal to 8 square centimeters approximately. Therefore, 5 plus 8 is equal to 13 square centimeters. The area of this figure is estimated as 13 square centimeters. Next, coming to this figure, we will count the fully occupied square centimeters. 1, 2, 3, 4, 5, 6, 7. These 7 are the fully occupied square centimeters. 7. So half occupied square centimeters, half square centimeter. This can be taken as half square centimeter. Only one half square centimeter is there. Only 1 half square centimeter. And greater than half square centimeters. 1, 2, 3, 4, 5, 6. 6 greater than half square centimeters, which are taken as 6 square centimeters. Therefore, total area of that figure is 7 square centimeters plus 6 square centimeters, 13 square centimeters plus half. Therefore, 13 and half square centimeters. Therefore, the area of two figures is approximately same. It is 13 square centimeters and this is the 13 and a half square centimeters. Thus, we can estimate the area of irregular figures or figures made up of curved surfaces on a grid paper. Now find the area of the shape shown in the figure. Here it is made up of straight line segments. Therefore, there is no half square centimeters also. So all fully occupied square centimeters. Therefore, we can just count and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the area of this figure is 18 square centimeters. So thus you can find the areas of regular and irregular figures placing on a grid paper. Next, area of a rectangle. There is a rectangle shape. We have put it on the grid paper. Now find the area of the rectangle by counting the full square centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 square centimeters. The area of this figure, rectangular figure, is 20 square centimeters. But its length is 5 centimeters and the breadth is 4 centimeters. Therefore, 5 into 4 is equal to 20. 5 centimeters into 4 centimeters is equal to 20 centimeters square, or this is known as the square centimeter. Centimeter square or square centimeter. So thus the area of a rectangle is length into breadth. The length into breadth. Therefore, by counting the fully occupied squares, placing the figure on the grid paper, we found its area as 20 square centimeters. And also by finding its length and breadth, 50 centimeters and 5 centimeters into 4 centimeters also, we found that it is 20 square centimeters. Therefore, for a rectangle, the area of a rectangle is equal to its length into breadth. Therefore, 5 into 4 centimeters. Therefore, it is square centimeters. 20 square centimeters. So, thus find the area of a rectangle whose length and breadth are 2 centimeters and 1 centimeter. So, area is equal to L into B. Therefore, 2 into 1 square centimeter or centimeter square is equal to 2 square centimeters. Thus, if the length and breadth of a rectangle are given, its product gives the area of the rectangle. So, if the length and the breadth of a rectangle are If the length and breadth of a rectangle are 30 centimeters and 20 centimeters. Its area is equal to L into B. 30 centimeters into 20 centimeters is equal to 32600 square centimeters. Similarly, if the length and breadth of a rectangle are given like this, 3.5 centimeter and the breadth is 2 centimeter, then also A is equal to L into B is equal to 3.5 into 2 square centimeter. That is equal to 3.5 into 2 is equal to 7. 3.5 if added to another 3.5 it will become 7. Or you can multiply. 2 5s are 10. 1 is there. 2 3 6. 6 plus 1 7. And the decimal point is 1 digit next to 1 digit from right to left. Therefore we have to put here square centimeter. Or we can write simply as 7 square centimeter. So that's the area of a rectangle is the product of its length and breadth. But see that the length and breadth are in the same units, either in centimeters or in millimeters or in meters, kilometers, whatever. They must be in the same units, L and B. Then area will be the square units of that unit, square of that units. Here L and B are in centimeters, therefore area is in square centimeters. If both are in millimeters, the area is in square millimeters. If both are in meters, the area will be square meters. If the two breadth, L and breadth are in kilometers, the area will be kilometers squares.